Let's compare strategies for solving equations. We actually now have many. So if you have an equation with fractions, not an expression, but rather an equation with fractions, first multiply both sides by the LCD and then distribute. You can't do this to an expression because there aren't two sides. So you need both sides of an equation to do this with. And this is the fastest thing that will work because this is the quickest way to get to a line that no longer has fractions written. So for example, looking at the denominators x squared minus 9 and x minus 3, well, since x squared minus 9 can be rewritten as x plus 3 times x minus 3, that x minus 3 factor is already there. So we should really just multiply both sides by x squared minus 9. And then after distributing on the left side, things will cancel both on the left and right side so that you no longer have fractions. Now let's say you only have one copy of the variable written, then peel apart. Undo the last thing that occurred, right? So for example, in 5 times quantity 2x minus 1, close parentheses, plus 8 equals 49. The last thing that happened to x is that plus 8, so undo plus 8 by subtracting 8 on both sides. What if you have more than one x written? Then you're going to have to factor. And there's several different ways that factoring might look, but there might, if there's two copies of the variable written, you had to write the variable more than once, you eventually need to get to a place where you only have the variable written once, and factoring is going to do it. So for example, with 7x plus 2x equals 10, we often tend to just think about collecting like terms, sure, but what it really is, what's really going on under the hood is factoring out the variable x. So that's factoring, right? So you go from a situation of having to write x twice with 7x plus 2x to writing x only once with 7 plus 2 in parentheses and x written just the one and only time outside parentheses. Look, this is really the same deal. If you had 3x plus root 2x equals 10, you should just factor out the variable x. If you have a quadratic, there's likely the case that you have x written multiple times, so x squared minus 13x plus 30 equals 0. Then you can factor the left side. X minus 3 times x minus 10 equals 0. So again, factoring is the thing that helps. You then after that would use the zero product property. If you had x squared plus 6x equals 10, well, subtracting 10 on both sides isn't going to work out so nice. Factoring won't work out very well. So instead, add the number 9 to both sides, which I get that in x squared plus 6x equals 10. There's no 9 written, but we're completing the square, and so adding 9 to both sides is helpful. And then the left side is a perfect square. And when you rewrite it as a perfect square, x plus 3 quantity squared, that's also a form of factoring, to be really honest. Take a look at how x squared plus 6x plus 9 equals 19, you end up saying x twice, whereas when you write x plus 3 quantity squared equals 19, you literally only write an x once. So all 4 of these examples involve factoring at some point. And then the third and fourth examples, these are quadratic examples, and you either would factor and apply the zero product property, or after completing the square, there's really factoring involved there too. So that was just a reminder of ways of solving an equation that has a variable called x. And then we've lately been looking at equations that have variable x and variable y. And an equation in x and y always has a picture or a graph. And what's the connection? So how is an equation in x and y related to its graph? Well, the point xy is part of the graph if xy satisfies the equation, and the point xy is not part of the graph if xy doesn't satisfy the equation. So said differently, xy is on the graph if xy satisfies the equation, xy is not on the graph if xy doesn't satisfy the equation. There's a one sentence way of saying this using if and only if. So x comma y is on the graph if and only if x comma y satisfies the equation.